everyone. Welcome to my talk entitled Intent on Being a Good Android Citizen. It's not that easy to read with the OWASP template, but its subtext is defensive strategies and techniques for developers. So before I start, I just want to spend a few moments talking about what a defensive strategy is. And a defensive strategy is a way of writing your code so that it's always secure. And the opposite of that is it's sometimes possible to write code that is secure in some circumstance and insecure in another circumstance. An offensive approach aims to be secure always. And this is quite important for developers because they often don't understand the various contexts that their code could be used in. So just a little bit about me. I'm Andrew, with a funny spelling. I'm a security consultant. What you need to know about me is that I used to be a software engineer. I used to be a developer. And I've been working with Android for at least the last 2 years now at this company called Cigital, doing predominantly Android assessments. I do other stuff, but it's mostly been about Android for the last 2 years. So when I talk to you today, I'm talking to you a little bit as a developer and as a tester. So what about you? Can I just have there's not that many of you, can I have a show of hands? Are any of you developers? So one developer, 2, 3, 4, excellent. And not a developer, show of hands. Okay, so nobody's perfect, but so I'm speaking primarily to developers, but I'm also speaking to testers. So if you're a developer, you really want to be able to write secure code without thinking about all the edge cases, and that's really where I'm speaking to today. So best practices, gotchas. If you're not a developer, I'm hoping there's still something in this talk for you. Perhaps you need to write remediation guidance for assessments that you've done, and remediation guidance is not actually always that easy to write. I'm not going to talk about attacks, but some of this may still be useful to you. And even if you can't lift the remediation guidance, the approach behind the remediation guidance might chime. So my agenda is to do a quick primer, and then I'm going to talk about 6 rules. 6 rules for intenting safely. And when I looked around on the internet, you have 7 ways to hang yourself with Google Android, 3 ways to ace your first interview, 5 ways to be secure. I couldn't find anything 6 rules for something. It just happened to land up that way. So the rules are: be explicit about exported, and that's just about not leaving things to chance. And that's really simple. It's something you can do in your sleep, but if you don't do it, it can have severe consequences. The next one, point 2, is same old, don't trust the input. Number 3 is a special case for assuring intent origin when you're handling system events, or when you're handling events that you think are from the system, but they may not be from the system. Common mistake. Point 4 is about being explicit when you're talking within your app, in intra-app communication. Point 5 is speaking to data sensitivity, and point 6 is validating some assumptions that if you don't validate the assumptions, the whole security of your app could be undermined. This is not actually that easy to use. It's a bit flaky. So what is an intent? Just a quick primer. Intent is a way to make a way to do inter-process communication, something along the lines of a remote procedure call between a sender and a recipient. And there's the option of having a return path. And when we, as developers, tend to think of intent in sort of a holistic way. Under the hood, there's a few different concepts. There's the addressing, the naming of the recipient. There's the data that's exchanged, and actually the interprocess mechanism that's used, the RPC call. But when we tend to think of these, and for the purpose of this talk, you tend to think of a single abstraction. So here's an example, a specific example. I have a sender who wants to start an activity, which is a piece of user interface the user can interact with, creates an intent, says, I want you to do this action, and here's the data I want you to use, dispatches the intent, and presumably the activity reacts to that and performs the business logic. Really simple. So, just speaking to the three things I mentioned earlier, intent can be something called implicit or explicit. And that's explicit really means you name the target. So there's an example. I want this intent to go to the greeting activity in greeting package, set it up and dispatch the intent. An implicit intent is one where the sender creates the intent and lets the system choose who the recipient is. So here's an example. I want someone to perform the view action. Here's the data. Here's some additional information. And the system chooses the recipient. Now, in order for all of this to work, the receivers, the recipients, need to somehow advertise the kinds of intents they can handle. And that's done very flaky. How do I scroll back? This is, yeah, that's done. Is there another way to control this? Because this is very, yeah, I think I will. So I'm going to use the keyboard. So that's done using something called an intent filter, where the recipients advertise what kind of intents they're interested in. The system goes through some sort of resolution process. The intent filters are not security boundaries. Everyone knows that, but it's a common source of mistakes that lead to security vulnerabilities. And finally, intents, and this is really important, intents can be, in the top example, between apps, inter-apps, or they can be intra-app within an app. Now, as the diagram there shows, that's a developer abstraction. There's nothing about the intent API that actually sends the intent within an app. Well, there is an edge case. You can actually do it. In process, you get a strong guarantee. But in general, that's just an abstraction that the developer sees. And as a result, if they don't do it correctly, if they make mistakes, then an attacker can be in the game. The final part of the primer is just going over something called permissions. Most people know what permissions are. If you're an Android developer, this will be old hat. But permissions are like labels in an access control system that protect IPC participants. They protect other types of data, but for the purpose of this talk, I'm only interested in intents. And the important thing is that intents they are predefined, and developers can define their own intents. And in the beginning, every app has no permissions. It starts off having no permissions, and they request permissions, and there are three ways, for the purpose of this talk, three ways that they are granted. If the permission is classified as normal, system grants it automatically. If the permission is classified as having protection level dangerous, then the user has to approve the installation of an application. And finally, there's a signature or signature system, which I'll treat the same. And that is that a permission is granted to an app if it is signed with the same certificate as the permission in which it was declared. So app 1 signed with the developer's certificate, app 2 signed with the same certificate, app 2 requests permission in app 1 and is granted that permission automatically. So here's some quick examples. Permission protects recipients. There's an example of a receiver, and it says, if you want to talk to me, you need to have this permission. So what does that mean? It means that a sender that has bind device admin can talk to this receiver because you must have bind device admin. In this case, it provides assurance that only the system can talk to my example receiver. Whereas a component that does not have the permission can't talk to my example receiver. So permissions protect receivers. But permissions protect broadcast senders. And the important bit of code is the one at the bottom. A component creates an intent, says, you can have this, you can receive this if you have this permission, must have this permission, and then just dispatches the intent. So here's the same example diagrammatically. The recipient says, to receive this intent, you must have this permission. Some receiver is able to receive the intent if it has been granted the permission, but if you do not must have this permission, you don't get the intent. So that's really, really straightforward. So let's look at my 6 rules for intenting safely. Be explicit about exported. Treat all input intent data as evil. Verify the intent origin. Use only explicit intents. Avoid sending sensitive data. And validate your assumptions. So let's look at the first one. So this is so easy, there's no reason not to do it. You can just do it in your sleep. So there's an attribute that controls whether a component is public or private. It's called exported. And if it's true, it's public, meaning other apps not having the same user ID can send intents to your app. And if it's false, that means only root or apps having the same user ID can send intents to your app. So there's an example. If it's true, app 1 can send to app 2. If it's false, app 1 cannot talk to app 2. If they have the same user ID, then they can still talk to each other. And the question is, what if you don't use this flag? What if you don't use it? Now, most developers will be aware of what happens, but the actual answer is it depends. Now, it depends is not a good answer from a security perspective. You want certainty. It may be exported, it may not. If it has an intent filter, it's exported. But if it's provider and you don't have exported and the min SDK version is 16 or less and the target SDK version is 16 or less, then it actually is exported, otherwise it's not. That's an example. So we don't want uncertainty. And that's why you need to be explicit. The default value is inconsistent. And the second reason really is it conveys design intent. It's the idiomatic way of saying this should be for intra-app intents only. And if you don't do this, you open up yourself up to attack. Rule number 2 is same old, same old. Again, this is so easy, you can do it in your sleep. For all intent handling code, internal and external, do some basic actions. Put a preamble in your intent handler. So the first thing I do is basic stuff. I check the action is not null. If it's not null, I check it's the action I expect, and I do that for everything else I depend on. I mean, it's input validation 101. Validate the action, validate the extras, do everything else you need to do. Check that. So let me give you an example of what happens if you don't do this. And this is, I've assessed 2 apps that make these basic mistakes. So here I have a screen lock app. It's got something really critical running. It must be running at all times, and I've got an attacker. So what can my attacker do? Well, let's say my screen lock app just does this. It just gets the action. It says if the action is the action I expect. What can the attacker do? Well, the attacker can create an empty intent. Simplest of attacks. Creates an intent, doesn't put anything in it, names the screen lock app as the target and sends the intent. Now, how do we know it's an empty intent? Right? It's a hollow block there. Should be a good hint. And what's going to happen should be fairly obvious. Null point exception, app crash, screen lock bypass. Trivial mistake. Just because I didn't check for null. Here's another example. Here I forget to check the action. I need to put a bit of background around this example. So here I have a receiver. It advertises that it's interested in something called a package added action, an event. This particular event is guaranteed to be broadcast by the system. It's a protected broadcast, and my receiver is taking some action when the system sends this broadcast event. And here's the code. This is what it does. This time it checks the action, forgets to check the value, checks null for null, forgets to check the value. And then it uses some data that's been put in the intent, some extras. So what can an attacker do? Now, attacker can't send package added because that's protected. System, in this case, protected broadcast system will check that. But the attacker can send intent foobar. Create an intent with action foobar. He can address my receiver and he can send the data. And he can spoof the intent because I didn't do something as simple as checking the action. And I can get that app to do something it shouldn't be doing. So that's a really easy rule to remember. Just do input validation. Very easy to do. So rule number 3, special case. For system broadcast intents, verify the origin. Now this really speaks to broadcast intents that you think that the system does send, but you may be mistaken in thinking that's only the system that can send them. So you can fix this in 2 ways. You can infer that it must be the system by saying, well, I'm going to put a permission around my receiver and say, only the system, this is a permission only the system can have. Therefore, if I get this intent, it must have been the system. Or you can do it programmatically. And I'm going to show you the easy way because generally declarative security trumps dynamic checks. But this is the first way. So before that, I'll just explain why. Well, I think I've explained it already. So many broadcasts are assumed to be protected broadcasts, so they're vulnerable to intent spoofing. So here's an example. It's a common thing for two-factor apps to have SMS as an additional channel. So here's part of my app, GWizBang multi-factor auth receiver. It's interested in SMS received messages, and presumably inspects the message and maybe presents a pin on the screen for the user to type into their favorite banking website. They type it in, they get access. So the system does indeed send SMS received messages. But so can an attacker. An attacker can't do that implicitly, but they can do it explicitly. So they can just create a new intent, SMS receive, name the target, boom, send it to my app. And they can spoof that second factor. So the way to fix that is, by the first example, indirectly, is to say, well, if you want to send this to me, you must have the broadcast SMS permission, which I know is a signature permission that is owned by the system. Therefore, I've verified the origin. Only the system can send it. So rule number 4, use explicit intents for internal communications. So internal communications really is just a recap. When you have components within an app, intra-app components talking to each other, and as I said, showed in the primer, that's really a developer perspective. So just to remind ourselves what an explicit intent is, it's creating an intent and naming the target. Now, I've got 2 stars there because I didn't want to do this because there's always an exception. So, and in this case, there are actually 2 exceptions. I need to be specific, unfortunately. So, for internal communications, you always want to use explicit intents. But Android does provide a stronger guarantee via something called a local broadcast manager, which allows you to send intents in process. So you don't even have to worry about security. And here's an example. I register a receiver, and later on, within the app, I send a broadcast intent to the receiver, and I don't have to worry about security because it's in process. I don't have to worry about permissions. It's the best kind of security. That's the exception. But for everything else, you want to use explicit intents if you can't use local broadcast receivers. So why? This is nothing new. 2011 there was a very good talk, 7 ways to hang yourself, Google Android, and it's called unauthorized intent recipient. I'll just take you through it very quickly. So there's my example. I create an implicit intent. I put some data in it. I put an action in, and I dispatch it. And if you recall, the system chooses the recipient. So I have my legitimate app and I have my bad app. And my bad app wants to get that intent for nefarious reasons. So what can you do? Well, if you remember, apps advertise the kinds of intents they receive. So bad app can define an intent filter, and he can load it, he can stuff it to be the preferred recipient. And if all else fails, he can even set a priority to grab the intent. Now, the way the system handles these things is slightly different for activities or broadcast receivers or services. But usually that's not an obstacle. So this is my second edge case, if you don't know the addressee. Now, I wonder if any of you have ever had a situation where you find a SQL injection and you say to the developer, use parameterized queries. So yeah. So they go off, and they bring it back, and you test it, and it's still vulnerable to SQL injection. You say, show me the code, and they've used a parameterized query, but they've done the string concatenation right on top of it. This is this case for Android. So I've said use explicit intents. So here's an example. Down at the bottom, and I really see this, they create an explicit intent by setting the target. So this is explicit. But before they do it the equivalent of the string concatenation, and they query the system, and they say, system, who's interested in this intent? Grab the name, then grab the target, whether it's an activity or a service. They get the name, and then they create an explicit intent from it. Well, what they've really done is create an implicit intent. And a lot of code, some apps, when they try and write plug-in functionality, they do this kind of thing. They want plugins, and so they go through this dance. So this is the edge case. So if you do that, just put a permission check around it. Say, well, yes, okay. you must have this permission before I send this explicit intent. Now, the Android API has a send broadcast with a permission. But start activity, the activity RPC and the service functions to start a service stoppers, those do not have permissions in the signature. I think that's a pretty strong design hint that you shouldn't be doing this at all. But if you do it in a secure way. How am I doing for time? Okay. Yeah, okay, good. 2 more. So the next one is avoid sending sensitive data in intents. Now, there are a lot of good reasons for doing that. So here's an example. I create an intent, I stuff it with sensitive data, and then I send it. Now, you should avoid not doing this. Or if you're an assessor, you should look at this and suggest as remediation guidance, don't do this. It's well known, you have the sticky broadcast, the leak information, you create a sticky broadcast, it's totally unprotected, it gets rebroadcast to new receivers, don't do that. You can hijack services, and services tend to be in a trusted, once you start a service, it tends to be trusted, you may exchange information with the service, there are other ways you can do it. So I'm going to show you another way. So probably many people are familiar with this on Linux, where I start a program, and if I pass sensitive information on the command line, it leaks. If I just query the proc file system, look at the command line, I can see all the sensitive information. So that's kind of, many people are familiar with that problem. So you can do the same thing on Android. It depends. I mean, it depends, but that can happen. That can happen. You can get the base intent for activities in new tasks if you have the get task permission, and if there was any sensitive information in there, then you can just pull it out from the base intent. So it's the analogy for the top part of the slide. Now they've done some stuff, they've tweaked some stuff. You now need a different kind of permission. I'm not sure if a user would actually understand that permission, but they've fixed it. So this is a little bit more nuanced because you need to change the design somewhat. Actually changing the design has some advantages. But the basics is that you pass a reference to the data and you have the recipient fetch the data. You don't pass the data itself. And that puts the onus on the recipient to have the permission to then go and fetch the data. So it simplifies the design in some ways. It's something of a trade-off. So last rule is validate your permission assumptions on startup. What does that mean? So the question is, you have a permission. Is that permission actually your permission? So this is a well-known problem. The first permission registration wins. But it's only sort of recently people started to talk about it a little bit more. It's been known for quite a while. It's the standard behavior. So here's an example. Bad app is installed first and declares good app's permission and downgrades the protection level to normal. And then requests that permission. It doesn't need it's normal, so it's just granted automatically. And then good app comes along later and says, well, yeah, I want to protect myself with good app.permission. And I'm going to make this protection level signature, so no one except my developer can grant this permission. So there's Android permission. And then I protect myself with that permission. I say, oh, my receiver, only you must have this permission to talk to. So the entire sort of fabric of my app depends on whether that permission is really what I think it is. So why is that important? Well, I've made an assumption. I'm protecting my app with my permission. And that's the basis of my assumption. And if that assumption is wrong, I actually have no protection whatsoever. So the fix is do a dance, go through your permissions, declare it all that, compare it to all the other permissions in the system and have a look at them. Now, someone has done that for you. It's on GitHub. You could put this code in your startup for your app. There is a bug in that code. When I reviewed it the other day, the author is aware of it, so hopefully he'll put a fix. It's an edge case, so hopefully it won't affect. Sorry, I'm running quite fast then. So there is a bug, but he says he's going to fix it. So I'm running a little fast. Okay, so summary. Be explicit about exported, rule number 1. Treat all input as evil, rule number 2. For system intents, make sure you're sure that it's from the system. Use explicit intents. If you're going to talk internal communications, use explicit intents. Avoid sending sensitive data in intents. And finally, validate your assumptions that you make about the security of your app when it comes to permissions. So that's all. I'm running quite early, but thank you for listening. And if there are any questions, do so now.
Would you recommend separating signatures for So would you recommend separating signatures based on the how security intensive the apps are?
Would I recommend separating signatures? Could you give me an example?
I have banking apps and I have some marketing apps, and would you recommend having different signatures for those?
For different apps. So the apps are signed with different signatures. You're not talking about permissions. You're just talking about signing apps with different signatures. So I'm not too sure I fully understand the question, but I'm going to answer it in a different way, and hopefully I answer it in this. I'm actually not a big fan of permissions, of creating loads of permissions in the first place. I think a lot of things that are done with permissions can be done with an additional step, additional screen where the user approves things, and you can actually eliminate the requirement for permissions. In fact, it's Google's advice, don't go creating loads of permissions because it just complicates things. So back to your question about different apps, I mean, that depends on the context. Are those apps, is there some trust relationship between the apps that they need to be signed by the same certificate? And if there is, then, and they need to, they are logically part of the same app, they share the same user ID, or they need to use signature permissions, then you have to sign them with the same certificate.
But otherwise, should that be something of a concern?
So the rule of thumb is minimize trust between apps. So that's your starting point. Apps don't trust each other at all, and there should be no signature permissions. They're not signed by they're not running on a shared user ID. That's the starting point, and then slowly relax those constraints as you find the requirements really dictate that you need to do that. But as a design guideline, start with no trust, and then really challenge those trust assumptions as you develop the app.
Thanks, Andrew. It was really good talk, actually. So just a question on the last issue described about the way the platform handles custom permission.
Yes.
Don't you think it's something that maybe the platform should do in a better way?
There's been a debate going on that for years, and they're not going to fix it. It's not going to happen. There's a conservative strategy because they don't want to break things, and you can follow the debate, but that's the strategy it's been fixed for system permissions. Previously, you could actually hijack a system permission. There was a paper called pile-up flaws. They fixed that, but for custom permissions, it doesn't look like it's going to be fixed because especially when you have apps from different vendors. You have Twitter and Facebook, and Facebook says you need to install. I need to be installed first, and Twitter says no. Why? And they both need some sort of, if they want some sort of permissioning system to talk to each other, and they need to request those permissions, then they need to be declared, and that's why that behavior exists, and they're not going to fix it.
Hi. Any particular considerations or gotchas for push notification intent broadcasts?
For?
Push notifications intent broadcasts.
It's not an area I'm familiar with, so I don't have any. But I will look at it straight after this talk and see if I can dig something up. But I don't, sorry. Hi.
Would it be possible to find all the bad intents by some kind of automated script, regex, or something like that?
Sorry, to find all the
badly designed intents by some kind of automated script, some kind of regex or something like that.
Well, the easy part is finding all the intents and documenting how they sent. Whether they're badly designed or not, I don't see how you can do that in an automated way. And what we do when we do assessments, so we look for these kinds of signatures, but then we have to check, we have to fire them off and check, see what they do, because the system's decoupled. You need to go through some dynamic verification process to see sometimes what the effect is. You can't tell it statically. So the easy part is finding it, but whether it's badly designed or not, that's not a step that can be automated easily.
I thought about, for example, mass scale assessment of, for example, all the applications on the App Store, which was recently made.
Yeah. So there are things in progress that do things on mass scale. They'll inspect the code, they'll inspect the manifest, and they'll just do really basic intent fuzzing. But then there's no observation as to whether that is a business problem or design problem. They're usually just trying to inject malformed intents and see whether it crashes or see what the behavior is.
Thanks.
Okay. Thank you.